Given the electronic configuration of an atom by a student, the question is what is or are wrong with this configuration. Now what I want you to do is pause the video, list two things wrong, and then play the video to check out the solution. Now you are back. Let's look at the key concepts to be successful at this problem. First is to identify the atom. Second is to highlight the four quantum numbers. Third is the N plus L rule. And last is to obey the Pauli exclusion principle. To identify the atom, since this is an atom and not an ion, the number of electrons is equal to the number of protons, which gives the atomic number. Therefore, the sum of all the superscript numbers at the right of the letters represents the total number of electrons. As a result, the result here is 2 plus 2 plus 5 plus 2, which equals 11. In an atom, 11 electrons means 11 protons, which is the 11th element on the periodic table called sodium. The four quantum numbers will be applied to this element, and they include the following. 1. Principal quantum number is notated as N, and this reflects 1. The energy level. 2. N are positive integers from 1, where n equals to 1, 2, 3, and so on. And third, on the electron configuration, the first number is represented as N. Next is angular momentum quantum number. It is notated as L. This reflects the orbital shape. Next is that it can also be called sublevel or subshells, followed by L is in the range of 0 to n minus 1. And on the electron configuration, these are represented as the letters, where L equals 0 is spherical, which represents S, and 1 for L is equal to p lobes orbitals. Note that N increases as its energy increases, and for L increases as its energy, except for the 4s and the 3d. Third is the magnetic quantum number, notated as M subscript L. This reflects the orientation of the orbital in space. Second is that they must have a maximum of 2 electrons in the orbital within the sublevel, similar to the Hund's rule. Next is that the ML have integer values in the range of -L to +L, including 0. And finally, here in this electron configuration, the S, which is where L is equal to 0, has 1 orbital, which is in this case represented as the number 0. However, the P, which is where L is equal to 1, has 3 orbitals, where it is represented as +1, 0, and -1, as shown right over here. Now, the final one here is called the spin quantum number, and this is notated as ms, and this reflects the intrinsic angular momentum of an electron, and this is where the electrons are known to have unique quantum number, and this is with the upspin as indicated as +½ and the downspin as -½ Now, parallel spin is when the electrons in different orbitals have the same ms values. When electrons are paired in the same orbital, they have opposite spins, in this case the positive half and negative half. Next is the N plus L rule, which is used to rank subshells based on increasing energy. This can be reviewed on the periodic table, and this here states that the higher the principal N and the angular momentum L quantum number, the higher the subshell energy. Therefore, the subshell with the lower energy is filled first, and this here is applicable when it comes to the 4s and then to the 3d. Next is if the N plus L value of more than one subshell is the same, the subshell with the lowest N value has the lowest energy, in this case here the 4p, and the orbital are filled with electrons first, and then that is followed by the 5s. Now this here is not applicable to sodium, and this is going to be addressed in future videos. The final concept here to keep in mind is the Pauli exclusion principle, and this here analyzes the electrons based on the 4 quantum numbers, and this here concludes that no 2 electrons in any given atom can have the same set of 4 quantum numbers, as shown right here, where the ms here is different from the ms over here. Therefore, what is wrong with this configuration shows two things. First, that is, it doesn't follow the N plus L rule, and finally here is that it doesn't follow the Pauli exclusion principle. Therefore, the solution here is based on the number of electrons. We determine that the atom is sodium with 11 electrons. Next is using the N plus L rule, the order of the orbital from lowest energy to highest energy is 1s, 2s, the 2p orbitals as shown right here, and finally the 3s orbital. Now, based on the Hund's rule, which focuses mainly from the magnetic quantum number and the Pauli exclusion principle, the subshells with more than one orbital, in this case like the 2p, must be half-filled as shown right here, and then we have the next step, which is pairing those unpaired electrons, and this here shows that it is going to be completely filled, and that is the maximum number of electrons here to be 6. And then finally here is we add our final electron here, which is going to the higher energy level, the 3s. Therefore, this here is the correct configuration for sodium.